Hello. Hey, hey.
Hi, everybody.
Hello. I love this waiting part. Just quiet and awkward. I had the urge to make this class particularly weird, just pick one person and make unflinching eye contact with them the entire class. I don't think I could keep it up for 2.5 hours. But I like the idea. It's 6. I guess I better actually start this thing, huh? Okay, so some of you I know, some of you I don't. This is kind of a follow-up to a previous class, but I guess you guys are like leveled up to enough to the point where you can see some of the tougher stuff. So this class is going to be covering pretty much the second half of all the subjects that you would see on the HSE or GED. If you've poked at essential education at all online or anything similar, I'm literally just using the course outline from that and just working my way through it. So if you've been following along with that, then you're probably in a good spot. If you haven't, then I don't know. I sent out an email the other day. Hopefully most of you got it. If you haven't, let me know later. But that has not only links to stuff relevant to this class, but also the previous class. So if there's something I cover and you're a little iffy on it, you can actually go back and see the classes that I taught before. I have all those uploaded on YouTube. Past that, also in that email is a link to a Google Drive folder, well, a couple of them. One of them is for the previous class, and that has all the slideshows and notes from that class that I scan in after every class. And one of them is where these slideshows and my future notes are going to be put. So everything should be available to you guys really easy. Just click on the link in your email and there's the entire class. So trying to make it as acceptable as possible. If anything throws you guys off, let me know, shoot me an email, start screaming, whatever. Get my attention somehow and we'll at the very least cover it at least a little bit. See if I can iron some stuff out. So I got the word back on here because, like I said, some people were in the class last time. So we'll go over a little about myself, expectations for the class, its rough structure, what you really need. Materials is really easily have something to write with and something to write on. That's pretty much all you need. For some of the funky stuff, you might want to have a calculator around. I'll still be working everything out during the lecture part. So if you don't have a calculator handy, it's not going to ruin your world, but if you're following along with one, it tends to stick better. So might be good to keep in mind. So I am Ben Wassum. It rhymes with awesome. It also rhymes with possum. Everybody, when I was in kindergarten, figured that one out really fast. That was great. I don't get why it was funny, but you know, whatever. Kids are stupid. So I have an associate's in science, which lets me teach this class and absolutely nothing above it, which is great. I've been through calculus 1, 2, 3, differential equations, and linear algebra for funsies. So yeah, if you have like higher level stuff you ever run into that you need help with, and my email is still active and I haven't quit in a raging firestorm or something, you can always email me like 2 years down the line for help and I'll help you. I don't even care. Why not? So I've been tutoring at WNC since 2008. I actually started in the Academic Skills Center, which is no longer a thing. Used to be down the hall. Now I think it's an art room, and that makes me sad. But essentially, that got merged into academic coaching in the library. So I was tutor, lead tutor, academic coach, and then I hopped over to Excel. So now I'm a part-time instructor. So I've got a lot of math under my belt and a lot of experience helping a lot of different people with a lot of different things. So if there's anything specific that throws you off, if I'm not covering something in class, you want to go over it, we can hash out time, figure it out, and basically fix that. Also, just call me Ben. I hate Mr. anything. I hate it. I absolutely hate it. I hate any form of formality. I don't like that. Just not a fan. This is taught at a class at a college, so a lot of people haven't been to a college before. I get a lot of people who were previously in high school. So if you gotta go to the bathroom, don't worry about raising your hand. Just go. Advice you can give 6-year-olds, because you know what? Locking them up in a classroom, that's stupid. All right. So as you might be able to pick up, I actually do care about you learning. If you want to figure something out, we're going to figure it out. Got lots of ground to cover in this particular class. And as on there, I ramble off on tangents a lot. I have severe ADHD. If I stay focused for an entire class, I don't know what happened. I don't know what's in me. We got to get me a regular amount of that. But yeah, if it's interfering, rope me in. So expectations. So for the homework, I'm not really assigning homework. Just expecting everyone to go on to essential education because I can't really gauge how long you guys are doing homework. You know, if I give you guys like 10 problems a night and you go home and you bring them back to me, some of you might take 5 minutes on them. Some of you might take an hour on them. It wouldn't be fair to you guys if I just locked everything in as like a certain amount of time. Essential education does in fact count the time that you're on there towards the hours that you have in the Excel program. So you could potentially be in here, you know, the entire class is going to be a grand total of what, 30 hours? You could be online 30 hours, double the length of the class, and get that much credit towards it. Please show up on time. This is generally a big problem in this class. Usually I have a steady trickle of people in the first 15 or so minutes, and every once in a while somebody pops in like an hour in. Try to be on time, because I mean, there's a 6-week class, so there's 12 lessons total. Got a lot of ground to cover. Don't want you guys to skip it. I will say that in terms of how I structure the class, usually the first chunk of it is reviewing the previous class. That way you guys have seen everything at least twice. Sticks in your head a little bit better that way. That way, you go home for a couple of days, you stew on something, you come back, and it's let's face it, by the next class, it's all gone, you don't remember. We refresh a little bit, and then if it's still causing trouble, ask questions. Basically, it's a good setup. It's a good setup. I got this. It'll be fun. So for communication, pretty much send an email if anything. If you can't make it to class, if something was confusing in the class, if you just feel like saying, hey, look, I found a frog. Look at this picture of the frog. Whatever. You need to communicate with me, shoot me an email. While you're in class, we got for people online, there's a chat box for Zoom. I can see that. Speak up, raise your hand, awkwardly make eye contact and look horrified, and shakily put up a hand so nobody can tell it's you. Whatever, I don't know. If you're afraid of public speaking, just remember there's a guy in front of you that truly hates public speaking. I have no idea why I took this job. Yeah. That fear that you get when you have everybody's having presentations and you just don't want to go to the front of the class. You just don't. That's me right now. I don't want to, but here I am. I was like, what happens if I quit? Like right before the class. Probably wouldn't go over well. And also I like getting paid. So that is a positive. And down there at the bottom, if you find yourself falling behind, reach out as soon as you can. It's math. It all builds on itself. Now, in this particular class, there's a bunch of different subjects we'll cover. There's a little bit of statistics in there. There's a little bit of probability. There's so little statistics, I don't know if it actually counts as statistics, but whatever. But there is a lot of algebra stuff that'll pop up. If that's giving you trouble, speak up, get my attention, whatever, because you don't want to fall behind in algebra. I've said it a lot, but even if you make it to calculus, calculus is 2 steps of calculus and 100 steps of algebra. Like, you want your algebra down. Now, geometry, everybody has trouble with that, which is going to be fun because that's very early on in this class. Blah, 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 essential education, blah, blah, blah. Yeah, you should all have a login for Essential Ed. If you don't, then, shoot me an email, bug me after class, whatever. We'll either track down your Essential Ed login or we'll talk to Elizabeth and get you one. Also, a note on Essential Education, if you haven't used it a whole lot, it's kind of annoying. You can't just go to essentialed.com. You have to go specifically to the WNC start page of essentialed.com, which is why that's one of the links in the email that I sent to everybody, because it's really annoying to have to remember app.essentialed.com/start/WNC, whatever. Just find something to click on, call it good. Also, if need be, Excel has a social media presence. So that's just to keep students connected and informed. The account name is Excel WNC on everything. If you follow that, there's probably updates. I don't know. I haven't looked at it, and I don't think anyone else has social media for a school page. I never cared. I don't know. I didn't even know there wasn't a cafe on campus until last month when I realized that everybody retired at the beginning of summer, and I had no idea. Really not absurd. And yeah, this is just a rehash of what I also covered. Bring something to write on and a writing utensil, scientific calculator if you can. As for what calculator to use, honestly, just the cheapest Texas Instrument calculator that pops up when you search scientific calculator on Amazon is probably going to be what you want. I wouldn't spend more than 15 bucks, but you know, you really feel like going all out and getting $150, bless you, getting $150 graphing calculator, you know, whatever. I did, but then again, it's lasted me a good chunk of my lifetime. All right, so any questions, comments, or concerns on this class? Anybody terrified? Anybody not looking forward to any of this? I respect that. Me neither, because you know, honestly I work in the morning. I want to go to sleep, but here I am. I would love to just curl up in a little ball down here and yeah, well, eventually I'm just going to be that jerk who like hits play on a recording of myself and goes to sleep. I had one of those at Oregon State. Just show up, TA's showing the video. Video's an hour and a half long. Never met the professor, never saw him in person once. But their last 2 weeks of the class were over a book that he wrote just so he could assign it to the class, and it was $100 per student. Couldn't buy it used, had to buy it new. Awful, awful, awful. If you end up going past the GED and going to WNC as a student, I can tell you that a good chunk of the math teachers, at the very least, truly hate having people spend money on this stuff. So a lot of them just use open source materials and you don't have to pay anything past the credits. I know that's the case with few of my coworkers in college algebra right now, which is like the first college level one. Okay. So math stuff. We're gonna do some math stuff. I over-prepared for this class, mainly because the last class of the, how do I phrase it? The last class of the last class. The last time the other class was supposed to meet, only one person showed up. So we just kind of hung out and talked about 3D printers. So I actually took all of that stuff that I never covered and shoved it onto here for everybody who might have been in that class who didn't get that. So that's the entirety of the charts and graphs lecture. I personally, when I can skip a class, it's usually the one I skip because I truly hated making examples for this lesson. Truly hated it because every one of them is a different chart or a different graph, and then I have to make questions on them. Like, I don't know how to make charts and graphs on my computer. I used Excel for like a year and called it good. So yeah, I shamelessly ripped off most of this from Google. I'm not gonna lie. Most of the class is shamelessly ripped off. But that's the charts and graph bullet. Everything after that is where I wanted to start this class anyway, which is pretty much just the entirety of 2D geometry. There's a bunch of stuff on different angles, different types of angles. And then most of the rest of it is going to be area and perimeter, rectangles, circles, triangles. Pythagorean theorem is fancy phrase for, hey, figure out the third side of a triangle. only on right triangles. And then being able to compare shapes and say whether or not they are the exact same shape or very, very close to it. So yeah, not my favorite lesson, not gonna be your favorite lesson, but you know what? We're gonna trudge on, we're gonna get through it, then we're gonna go to sleep. We're all gonna have a wonderful, I mean, it's 2.5 hours of math. You're all gonna sleep great tonight, right? Yeah, great. So this entire chunk is just a bunch of different tables, bunch of different things. You're probably familiar with a good chunk of them. Tables are the most basic one. You see a table, you know it's a table, there it is. There's also going to be circle graphs, bar graphs, and then a couple of obscure ones that I don't really, not really used to. So formally, tables are made up of rows and columns of data. So they're basically set up so you can take a glance at a table and be able to kind of absorb what's there and understand, you know, data very quickly. So like, I don't need to memorize the population of Pakistan. I can just glance at the table over here and call it good. So if you're doing problems with this table and it's like, how many people are in Bangladesh and Pakistan combined? You can just look at these two and add them together, call it good. Why you would combine those you know, states? I don't know. Maybe you're into overthrowing countries. I don't know. So here we have an example table. So I don't think sometimes I write down notes. Sometimes we just look at the slide. I'm pretty sure we're good just looking at the slide here. So how many countries are in the table? We just have to count the rows over there. Here's my little annotate thing for the people on the spotlight. So you got China, India, USA, Indonesia, Brazil, Pakistan, Nigeria, Bangladesh, Russia, and Japan. So that is, what, 10? 10 countries. Yay. Check. Which countries have over 1 billion people? Well, we go down to population. Everything seems to be sorted by population, which is great because that means I can ignore all of that and say, okay, these two. That is China and India. Which country has almost 20% of the people in the world? Well, we have a world population percentage over here, and right up at the top, we have 19 and change for China. China has a lot of freaking people in it. They have about 5 times as much as we do. Right, how many people live in the USA? That's quite quick. 314 million and some change. 433,000. What is the most populous country in each continent? At that rate, you can look at the continent table and say, okay, for Asia, we got China. For North America, we have USA. South America, Brazil. Africa, Nigeria. And, well, we can count Russia for Europe because there's not a whole lot for Europe hanging out in here, but you know, that's where it gets kind of hazy is in that area. Which continent contains the most populous countries? Well, if 3 out of 4 of the top are hanging out in Asia, I'm gonna go with Asia. I think that's most humans right there. And of the 10 most populous countries, how many are in Asia? 1, 2, 3, 4, 5, 6. Do we count it as 7? I don't know. 6.5. So a lot. A lot. Do we feel good about reading tables? I feel good about reading tables. Okay. So the next type of chart or graph is circle graphs or pie charts, whatever you want to call them. For some reason in the HSE and GED materials, it's called a circle graph. So you see circle graph, you think pie chart, bam, no problem. So they're very frequently used, but circle graphs always use percentages, and the entire circle graph always adds up to 100%. So if you look at like a newspaper circle graph and it's got two spots, and one of the spots says 40%, and one of the spots says 50%, and it looks like it's fully filled out, they are liars. 10%'s got to go somewhere. Sectors end up looking like slices of a pie, which is why we often call them pie charts. Those circle graphs are usually used to give you information about a topic broken down by different segments. So here we have a circle graph example that I absolutely stole from Google image search yesterday when I decided I really hated the example I've been teaching. I have a problem with honesty. I overshare. So this is a circle graph of favorite pizza toppings. So a survey of 320 people was conducted on their favorite pizza toppings. How many people preferred supreme pizza? So for number one, on how many people preferred supreme pizza, you would look at the chart, say, okay, supreme is red. It says 10%. So we would find 10% of the 320 people. If you're good with eyeballing it, you might be able to recognize that's just going to be shifting over a decimal, so 32. If not, you can convert that percentage to a decimal. So 10% would turn into 0.10 and multiply it by the 320. So you'd have 0.10 by 320, you still get 32. So we're going to end up probably doing that a few more times. How many more preferred cheese pizza over pepperoni? Okay, well, we got to get some hard numbers on there, right? I think I'll actually embrace the notes at this point because I'd like to actually, I'd like to actually have something, tangible to look at. We're not theater of the minding this. Oh my gosh, what's happening? Why is this on drop? I don't want drop. Clear everything. Go away. What the hell? All right, there we go. Not used to those controls. So what we have here are the percentages of each of the toppings. So this is all going to be of 320 people. So for each of these where I want hard numbers, what I'm going to do is I'm going to convert these to a decimal point. So instead of 50%, it's going to be 0.50, 0.25, 0.15, and 0.10. It's cheap, but it works. You can just shift the decimal over by 2, you got a decimal. Yay. And for each of these, we're going to have to multiply it by 320. Now, one thing I will say for the new students is that you'll see me use a dot for multiplication. That is a habit I'm never going to break. Usually you go from a multiplication symbol to a dot like that when you hit harder algebra problems, because having x times x on the same sheet of paper tends to be messy. So officially everything just turns into like a centered dot at that point. So yeah, clearing up some of that. So each of these, I'm going to multiply by 320 to figure out what we got. So I'm going to be really cheap about these. Half of 320, well, half of 32 is 16. So 16 with a 0 on it. There we go. 25% of the 320. Well, if that was half, then half of that. 80. 15%. I don't want to try to do that in my head yet. 10%. 10% we did, right? That was 32. Well, 15% is a little bit more than that 32, right? So if this is 10%, then 5% of this thing would have been half of that, so 16, right? So 5% is 16. We triple that, we would have 15%. So you triple that 16 to a 48. Did I just magically do 0.15 by 320 in my head? No, absolutely not. I am not that good at math. I am absolutely not that good at math, but you can absolutely be cheap about that sometimes. So if there's a way to be cheap about it, that's what I do. So let's go back to the questions. What did we need? How many more preferred cheese pizza over pepperoni? Okay. Well, I accidentally reversed those. Because that doesn't make any sense, right? This cheese pizza was less popular. I'm gonna edit that. What do you know? Now now it says how many more preferred pepperoni over cheese pizza. Weird. Wonder how that happened. That makes more sense, right? Because, you know, bigger number is bigger than smaller number. Okay, so how many people preferred pepperoni over cheese? Well, you would just take the pepperoni, subtract the cheese, and we have a total of 80 people. So 80 people preferred. Then number 3, what percentage of people did not prefer pepperoni or sausage? Okay, well, if we're going by percentages, we're going to need this stuff. So people who didn't like pepperoni or sausage, well, that would be the cheese and the supreme. That was 25% and 10%. So we'd end up with 35% of people. Now, how accurate is this graph? Probably not very. Probably not very. There's probably a sliver in there somewhere of people who prefer Hawaiian. And, you know, they might be heathens. They might not be. Whatever. Not big on pineapple on pizza. Pepperoni and bacon. That's what I want. Just the bacon. Pull up just the bacon. You just skip the pizza. Just go to bacon. Don't need too much bacon though, because then your heart will start beating funny. I know that from experience. That was bad. Did I go to the hospital? No, I ignored it. All right. So, we feeling good on circle graphs? Everybody happy? Nobody's happy, don't lie. All right, so line plots are weird. And actually the first time I really saw them as anything other than a bar chart was when I started looking at the materials for this class. Not really used to these. I don't think they're used very often. Now, the thing is, once I looked into it, I realized that we use this all the time and we never think of it this way. Because think of that, that graph kind of sideways. Like if the 0 through 6 was all the way down, then you had check marks next to it. What does that sound like? It's just tally marks, right? You're just counting. That's all a line plot is tally marks. Just set up and designed like a graph. So this was really weird to me. And I've never seen this one named like this or two written like this, but You know, if you've ever had to make tally marks on something, so like if a bunch of people were, yeah, cookies eaten at a party, and every time you have somebody that says 6, you make a hash mark on 6, and every time you say somebody says 2, you make a hash mark on 2, and yeah, that's pretty much it. Do they have to be X's? No, you can put a little picture of a pair if you want. It doesn't matter. It's just a thing to represent that that was somebody. So in terms of examples that I hate myself for writing, because then I realized, oh, I'm going to have to, you know, I'm going to have to write this down, actually do this. Truly hate myself for that. We have create a line plot with the following list of student typing speeds in words per minute. So essentially something like this, you would look at it and say, what's the lowest number? 37. What's the highest number? 44. And before I switch over to the notes, I'm going to write those down. But yeah, this is just, a line plot is just, you could also see it as, it might be referred to as like a frequency chart, because it's literally how frequent something happens. Switching over to the visualizer. I think the biggest problem I've made myself on this particular thing is keeping it straight. That's a lot of numbers. So I'm going to go top to bottom, left to right. So, or left to right and then top to bottom. Okay. Going to go rows. So 39, 43, 41, 42, 40. Cool, cool, cool. 37, 38. I bet you didn't think you'd be watching me do this tonight, huh? It's exciting, I know. 42, 37, 41, 40, 39. Just going through the motion. This is my life now. 42, 42, 43. You know, next time I teach this, I'm actually just going to write out this, or I'm just going to draw this out, put it in the slide. That would make more sense. I lost my place.
43.
Which one?
Oh, after the 42, 42.
Did the 243s?
Yeah. You did the 242. The next one's the 40.
I did one of them. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. How many do I got per row? 7. Wow, I made it halfway through my 43s. Okay. Good going, Ben. Also, if you see me make a mistake in this class, speak up before I, you know, make a complete and total ass of myself. Because I will make mistakes, 100%. I will make mistakes. Like when you take a test and you do just one small thing wrong on a problem and it ruins the whole thing, that's my life right there. That is my sweet spot. So if you see me do something stupid or see something that, you know, doesn't quite make sense, feel free to ask. I've had people say, well, I mean, you're the tutor, you're the teacher, I figured you'd know better. No, God, no. You guys make mistakes, I make mistakes, whatever. It's a human thing. Humans make mistakes. Thus, you know, I can refer to my dating history. Good stuff. That is one ramble you're not getting. Don't worry. All right. So, question-wise on these things, what are the most common typing speeds? Really stupid, easy questions after I've done this, right? All right. So at that point, we just look at the highest frequency. Now, if you are a well-organized human being, this line might be straight and these might be set up in a nicer grid or something. But I don't know about you guys, but when I graph something, it's a mess. It looks horrible. I really did kind of try to make a straight line here. Look at that. That's horrible. Like, just, if I was dropped as a kid, I don't remember, and that might be an indicator. So you look at this, and we're gonna just say which one has the highest frequency. So got a bunch of 2s, got a 3, 5 here, 5 here, and 5 here. Okay, so they're all tied for first, right? So we're gonna say 40, 42, and 43. Number 2, what percentage of students type at 39 words per minute? Okay, well, that's less fun, right? We need a percentage of students. So at that point, you need to know how many total we have. Let's be cheap about this. I had 4 rows of 7, that's 28. So we have 28 total data points. So when you're finding the percentage of something, you put that on the bottom of a fraction, and you put what you're after on top of the fraction. So what percentage of students type at 39 words per minute? Well, we only had 2 out of that 28. Don't do anything fancy. When you're taking the HSE, when you're taking the GED, you're either going to have a calculator in your hand or you're going to have a calculator on your screen. So skipping doing long division with that, 2 divided by 28, punch it in Mr. Calculator. Mr. Calculator is sarcastic and gave me a fraction. Yeah, this calculator will automatically reduce them unless I think there's like a squiggly yellow squiggly here that's an approximation button. So literally, if I want a decimal, I have to hit this first every time. Is that ruining my life? No, not really. It just happens every freaking time. All right, so I get something, so we get 0.0, I'm just gonna write the whole thing, 71429. 71429. Cool. So if you want to convert that to a percentage, you take that decimal point, shift it over twice, you get 7.1429%. You just move it over twice. Now, if it says round to the nearest 10th of a percentage, then you could round 7.1. If it says round to 3 decimal places, then you would say 7.143. I didn't specify, so I'm just rolling with it. Usually a good rule of thumb is 3 decimal places if they don't go out of their way to tell you. That was the most common thing that ever popped up in any of my classes was 3 decimal points. So that's what I'd roll with. All right, so number 3, which is going to go slightly lower because I put it right next to the answer for number 2. Number 3, how many of the students type at more than 40 words per minute? So it says more than 40 words, so it wouldn't count the 40. It would only count everything past it. So we count everything out here. Well, 42 and 43 were both 5, so there's 10. There's 13, plus another 4, so we'd be at 17. And it's not asking for the percentage, it's just asking for how many students. So that's it, 17 students. I do, when you have a word problem or something, I do recommend writing out what it is, the number of what, every time that you actually write down an answer. One, it's just a really good habit to be in. Two, it frames your answer correctly. So if you just said 17 to this, somebody glancing at it might be like 17 what? 17 desks? 17 turtles? I don't know. But the main thing is that it's a very common mistake to get to a point, have 17 of something, and then go back to the problem and say, well, crap, that's not what I'm actually looking for. I wasn't looking for the students. I might have been looking for the percentages, or I might have been looking for something else. So it's a good thing to have your units there, go back to the question, say, hey, does this answer my question? Yes, cool, all right. So I'm not gonna get partial credit, I'm gonna get full credit, because I was the king of partial credit for that. I made that mistake constantly. Do we have any questions on line plots? Yeah, me neither. Okay, that one. Actually for the review, and I don't know why it's in here, whatever. Bar graphs. We know bar graphs. We've seen bar graphs. Everyone's seen a bar graph. Where's my explanation on bar graphs? That's not good. Didn't copy. When was the last time I taught this? Let's try spring. Yeah, that's right. I'm that lazy guy. Nope, wasn't spring. Didn't make it that far. Well, winter. Did we make it that far in winter? Graphs and charts. Hi. Didn't get to bar graphs here. All right, the search continues. This is my life. There you are, you stupid slide. I've been looking for you. There we go. That's not cheap. I don't know what you're talking about. I put more than 5 minutes into planning this class, I promise. Ish. I don't get paid for that prep time. Kind of sucks. It can take hours to make these. So bar graphs. Bar graphs are a little bit more versatile because whereas like circle graphs are literally only useful for percentages. Now granted, the percentages might be tied to numbers, but really it's everything adding up to 100%. Line graphs just represent tally marks, basically. Bar graphs can kind of cover all of that. You can make a bar graph with percentages. You can make a bar graph with frequencies. I can't think of any other examples. Whatever, there we go. It's a bar graph. Are we happy with bar graph? You guys seen a bar graph? Not counting this one, because I know you've just seen this one. Not counting that. All right, I think we're good. So it usually just says either you'll have two axes. You'll have what you got on one of the axes, and you got how much of it on the other. So when we go to our example that I didn't want to immediately start on, we have a table, a bar graph of favorite colors. The colors are down one side, the number of votes is down the other. And from that, you can pretty much gauge all the information we might need. So it says how many more people voted for the most popular color than for the least popular color. Well, that's really easy to see based on a bar graph, right? We can look at red and say, hey, that one's got the bigger bar, it's got the bigger amount of votes, right? So that one's the highest amount of votes. The lowest amount's going to be down there at silver. It says silver. What's your favorite color? Silver. Man, that's gray. That's a mirror. Whatever. Okay, so red looks like it was 33 votes. The annotate thing. Hi, Spotlight. How you doing? Red was 33 votes. Silver was 9 votes. So 33 minus 9 would be 24. So that would be the answer number 1, 24. And maybe once I don't cover, maybe I'll do this as I go. How many people did not vote for silver or purple? Well, that question sucks, right? That means you have to add up all the other ones. So everything but silver or purple. Well, red was 33. We could skip purple. Blue looks like it's 21. Black is, well, these marks are 3 apart and it looks like it goes about 1/3 of the way. So we're going to say that's 22. Skipping silver. Gold goes 2/3 of the way past 30 to 33. So we're going to say that's a 32. Punch enter on Mr. Calculator. Get a horrible error because you hit a random button. And looks like 108. Nope, not 208, 108. And then what percentage of people voted for silver? Now that's less fun because if you want the percentage of something, you need to know the total amount. Well, we just counted everything but silver and purple and got it to 108. So if I take 108 and I add the silver, which was 9, and the purple, which was 22, we get a grand total of 139 people. So with that 139 people, we need to know the percentage for silver. Well, that would be the silver's 9 divided by the 139 people that we get. Embrace Mr. Calculator, be lazy with it, roll with it. I got 0.064748, blah, 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 blah. Moved over by 2 decimal points. We'll have about 6.5%. I like that. Less typing. So do we understand that particular math of finding the percentage? Good on it? Anybody concerned? Nobody's freaking out. Okay. You're silently freaking out. Freak out in my email later. Oh my God, I don't understand any of this. Okay, seriously, where are all my explanations? Is this my day? Am I having to call myself out for being lazy? Who proofreads? Really? Come on. These aren't the same examples, and that's probably why. Ooh, this one sucks. Oops, I just doubled that. I sure did. Okay, now we have, God, I thought this was long enough. Now we have a 72 slide presentation. Yeah. Okay, so I see a lot of people online right now. I see one of you has accidentally made your name algebra. Can you please type your name into the chat room? That is all I need. I can review it later. But I don't know who you are, so I can't give you credit for being here otherwise. unless you are in fact algebra as a person, then I am both surprised and confused. Sorry, I've been doing you wrong so many years. Which again, goes back to the relationship thing. Haha, see that? Tying it together. It's a good way to go. All right, so line graphs. Line graphs are pretty self-explanatory. You have a bunch of data points usually over time. You know, might be fancy in dealing with money and going over quarterly reports. Might be lazy and be over ice cream sales like this one. I don't know who's selling a ton of ice cream. Maybe this is Baskin Robbins, but I doubt they pull that much money a day. I don't know. I don't work for Baskin Robbins. If anyone does, let me know what their average daily sales are. I don't know. So since something is always changing over time with line graphs, the horizontal axis is almost always relating to time. In this case, we have days of the week, but like I said, sometimes it'll be quarters, sometimes it'll be years, sometimes it'll be seconds if somebody decides to make a really weird one. Now I'm gonna have to do that. And then along the other axis, it's just your values. So Sunday you might have made 410 bucks, Monday 440, etc. So here we have high temperature week of November 2nd in Zanesville, which may or may not be an actual place. I have no idea. I stole this graph. So much plagiarized material in these slides. You have no idea. If you ever need to know which websites are my go-tos, I can 100% link you. But chances are, if you Google the subject, it's going to be one of the ones on the front page. Okay, so line graph examples. Stolen graph, made up questions. Let's roll with this. So of the days shown, between which two consecutive days did the peak temperature decrease the most? So 2 consecutive days means days right after each other, right? So where did the peak drop heaviest between 2 days? Well, Monday and Tuesday. Yeah, Monday and Tuesday, right? That sucker just, you know, it looks like a crappy mountain, you know? That's what we got. Okay, between which 2 days was there the largest temperature increase? That one might be tricky because you might be just looking at one spot. Who's got an answer for me? Anybody?
Thursday, Friday.
That was the reason I wanted it to be tricky. No, it is not Thursday, Friday, because if you look off to the left, Sunday and Monday has a peak first. So when you read these, you got to be careful because your eyes are drawn to everything happening after that peak, right? You kind of ignore the first bit. And that's a common mistake. That's a mistake I make. That's a mistake you guys will make. Embrace your mistakes. Make them learning opportunities, not horrible situations that make you start screaming. Speaking of, how many people scream at the idea of having to come to a 2.5-hour math class? Anybody really unhappy about that? No? Nobody's gonna fess up to it. All right. I'll know in 2 weeks how many of you are still sitting here, because you will drop off. Some of you will not be sitting here in 2 weeks. That is how that tends to go. People always run away from this class. Case in point, the last class I taught, how many showed up for the last one? 1, just you.
Yeah, that was, anyone else from the last class is in?
Yeah, online.
Oh, okay.
Yeah, but not physically. Yeah, you people online, you should come in here. We're having fun. You can't tell, but there is in fact a disco ball behind the camera that you could see. Also, I hate that that thing's pointed at me this entire class. I hate, don't look at me. All right. Just hate it. I hate public speaking. I hate being on camera. I hate that I record myself and put it on YouTube. It's terrible. There's hundreds of hours of me just talking. The same problems. Actually, after a couple of weeks, this class gets into territory that I have not gotten to cover, because normally these classes are 8-week classes. This fall, they're trying something different, trying to do 2 6-week courses. And I was like, oh my God, I get to cover the whole thing. And then later on, I was like, oh my God, I don't have any of that prepared. So that is all going to be prepared like the day before or the day of class. If I am ever disgustingly unprepared, my bad. We can always just, you know, powwow over some of the stuff that we suck at, and we can fix what we suck at, like fractions. You all hate fractions, right? So you guys weren't in my last class. That's why you hate fractions. I made you guys.
It's a good class. It was a great class. Don't get me wrong. I hated it, but I learned a lot.
Yeah, you're welcome. I'm glad you hated it. I'm going to make sure all of you hate it too. But yes, I will shoehorn fractions in all the time to whatever problems I get to make up myself. I'm going to tell you right now that the main reason you guys hate fractions is because you have avoided them your whole life. You just want to get past them. You don't want to do it. I don't want to do it. That's the point I miss. Or I'm just going to write this. That's probably close enough. And you just move on, right? I'm not even kidding you. I could teach you guys fractions in like 10 minutes. It is not hard. You just, and it's all because when you're a little kid, they teach you fractions over like 2 months, right? They go over this stuff really slowly and they're like, here's how you add them. Okay, here in a month, here's how you multiply them. And you just do all this stuff separate. But if you learn it all at once, it flows a lot better. These are things that should not be taught separately. They make more sense when you stack them. And you're gonna see me do that a lot. Probably, I don't know. Most of this class I haven't covered yet, because normally the 8-week class gets about literally this far. This is usually the last class I get to. After this, I get to do a lot of typing. What the hell was I doing? Oh yeah, math. All right. So there we go. What is the range from lowest to highest in temperatures recorded? So we can all kind of see the highest one, right? That's kind of hanging out right there. Well, these guys tick up by 2, so that means the highest is 69. The lowest, that's as low as it gets. That'll be about 59. So the range from highest to lowest, it's only 10 degrees, right? Worst case scenario, you could always go from this point and start counting up. 2, 4, 6, 8, 10. Cool, there's another way to do it. It's cheap, but it works. And that particular way of doing it is only going to work if your graph does not look like something I would have made. Which is why I do certain graphs certain ways, and you'll see ways of getting around graphing terribly. And then we come to scatter plots, and no, do not link the slides. I don't actually know what that does, and I don't care to find out. So scatter plots are usually used to compare 2 different quantities using a vertical and horizontal axis. These are usually the messiest ones. Sometimes you'll have to do something called the line of best fit between all of these points. The most you can do without a computer is estimate that. Because honestly, these points are all over the place, right? And if I wanted to draw a straight line between them, it'd probably be along that, that way, right? But there is a mathematical way of getting a line that is close to the closest point to all of them the entire way across. And I have not done it. and I don't want to do it. That sounds terrible. That sounds like a lot of math. I don't want to play with that. So you either usually punch something into Excel, or nowadays there's online graphing calculators like Desmos.com, punch it into there, or you estimate it. So you would look at this and say, there's a point and there's a point, and I'm going to draw a line between them and we're going to call it good. Estimation's fun. So these are always jumbled graphs. Now the main things to know on scatter plots are correlations and the relationships between them. So if they seem to follow a straight line, they have a linear relationship. Get that? Line, linear. If they follow any other shape, like, you know, they're sloping upwards or something like that, then they have a nonlinear relationship. So they have a relationship, they're just not a line. So non-line. And if they don't have any obvious shape to them, they don't have a relationship. That's pretty clear, right? You got something that looks like raindrops on a piece of sidewalk or something, then yeah, there's no relationship. You can't tell where the next raindrop's going to be just based on the last one. Past that, there is correlation. If they're moving upwards, there's positive correlation. If they're moving downwards, there's negative correlation. Exactly like if you're playing with graphs of lines, if they're going down, it's negative. If it's going up, it's positive. Pretty basic there, right? So here is our example. The example is much nicer looking than the one that's hanging out on the slide. So is this an example of a linear, nonlinear, or no relationship? Thoughts? Anybody? Nobody wants to say anything? I don't want to say anything either. That's why I'm rambling right now.
I believe it's a linear relationship.
I believe you are correct.
Because it does go up.
Yeah.
But you could track each point.
Yeah, it's pretty much along a straight line. I mean, you know, they're wiggling, but that's kind of what happens in a scatter plot. They're scattered kind of in a straight line formation. So yes, it would be a linear relationship. Now, is there a positive or a negative correlation? Going up, right? So positive. Estimate sales at 21 degrees. Oh yeah, this is temperature to sales. Cool, that's the first time it mattered, right? I don't care about it past that, but estimating sales at 21 degrees, well, we don't have a point at 21, right? But if it's kind of going along that line, probably be in here somewhere, right? So you could round it, say 500, 450, all of those. Pretty much anything in this kind of range is a good estimate. So you can go smack dab in the middle of where you think the line would be, or you can go above it or below it. It's a scatter plot. So around 500, and estimate sales at 13 degrees. Oh yeah, probably gonna go right there, right? About 200 bucks. Like right in the middle. We feel good on scatter plots. I mean, I don't expect you to feel great about them, but you know, if you can look at these questions and be able to reasonably answer them, I think you're good on scatter plots. That's really, there's not going to be a whole lot. That's why I usually try to rush through this entire chunk of class, because usually it doesn't take long. Case in point, we're done with charts and graphs. Does anyone have any questions, comments, concerns? Nobody? You're all feeling great? Just don't want to do more. All right. So let's move on. So the rest of this class is going to be 2D geometry. I say specifically 2D geometry because you can guess what's going to come after 2D geometry, 3D geometry. Now, the nice thing about that particular class is it's literally like, they don't throw difficult stuff at you. So 3D geometry is just going to be like, here's a bunch of formulas for volume. Use them. Problem solved. So that's most of the geometry stuff is just going to be, you know, can you recognize what variables mean what in which formulas? If you can plug things into a formula, you're pretty solid. One thing I will say, usually have it in, where are we at? Where are we at? There we at. Yeah. On the HSE test and similarly on the GED, I just couldn't find the GED formula sheet for it. You are given most of the formulas that you would need to know. So if you're sitting in there and you're like, oh God, I'm gonna have to do circles. I'm gonna have to do spheres. How am I supposed to remember sphere's volume is 4/3 pi r cubed? Well, you don't have to worry about it. It's gonna be there. As long as you see these formulas and you can reasonably work with them, you're pretty much good. You're pretty much good. Now, before we get to those shapes, we got to play around with just lines. So here we have defining the 2D space. So you pretty much just play around with things being points, lines, and planes. When you're playing around with the 2D space, whole freaking thing's kind of the plane, right? You start playing around with the 3D space. Well, that's like having a sheet of paper sitting next to a sheet of paper. They're separate planes at that point. Now, are you going to have to play with that concept at all? But that's the idea. So a point is a location, but it has no size and it's represented by a dot. Believe it or not, the dot is a point. There we go. A line is a straight path made up of an infinite number of points. It has no thickness and extends in both directions indefinitely. So that's why when you're graphing lines, you got to put the arrows on both sides because it keeps going. You could graph 0, 1, 2, 5 billion, whatever, it's going to be on the graph, right? So your graphing lines goes on forever. Planes, the flat surface with no thickness and extends forever in each direction. So, for example, when we graph lines, we use a two-dimensional coordinate. That's our plane. It's a flat surface, and we're playing with it. That's pretty much it. So then we have shapes of parts of lines, I guess you could say. So we'll have a line segment. That's a part of a line that consists of two endpoints and all the points between them. So you can kind of just think of that as chunk of line. It doesn't go off in either direction. You just got a chunk of the line. It's a segment of it. I've said it a lot, but everything in math is named what it is, unless it was fancy, then it's named after who wrote it down first. So a line segment is a segment of a line. An endpoint is the point that it ends. So it'd be at the end of a line segment or on an array. An array is part of a line with one endpoint extending forever in one direction. So you got a dot, dot goes in a direction, dot keeps going. And an angle is two rays sharing a common endpoint. You know what an angle looks like. It's an angle. Yeah. It's an angle. We're cool with that. An angle is an angle. You know how to use them. We don't need to play with complicated, funky definitions. We're trying to understand as much. So angles are formed when two rays are extended from a central point, which we call the vertex. Vertex is a fancy word that I will use all the time. And it's kind of just like middle, it's like the middle point. It's the point where things come off from. You'll see it in angles. You'll see it in other shapes. You'll see it in graphs. It's just a useful word. Angles are usually denoted by the symbol angle. I can't say that out loud. It's an angle symbol. And are referred to either by their vertex or the 3 points comprising it, or a given name or number. So the angle we got over here can be written a bunch of different ways. You can do A, B, C to say, hey, I'm starting here, I'm going to this point, and I'm going to that one. You could do CBA, it can go backwards, whatever. You could say it's angle B because there's only one angle coming off of that point. If I had other, rays sticking out in this direction, I couldn't say angle B because, well, which one? Or angle 1 because we have a 1 in there. So you can call it any of those. They're all accurate. And like I said, or a given name or number. You could call it Bob if you wanted to, and that would be the angle Bob. We have named the angle. Good enough. Ooh, I forgot I have so much stuff on lines. This is gonna be fun. Most of this is gonna be vocab. I don't have a whole lot of examples for this because honestly, it's just stuff that you can read over and understand. Like adjacent angles here. Adjacent literally means next. So they're angles next to each other. So fancy definition, when a line is bisected by another line or ray, so it goes through it, creates multiple angles between them. Makes sense? So angles that share the same side are called adjacent angles. So 1 and 4, 1 and 2, 2 and 3, 3 and 4. The angles that are next to each other, they're adjacent. Pretty much it, right? So you'll also have a couple of terms that I'm not even going to lie. Every single time I look at these, I have to remember which one's which, and I end up like looking back at the slide or whatever. Not going to lie, I forget every time. But you'll have two terms: supplementary and complementary. Supplementary angles are two angles that add up to 180 degrees. 180 degrees. Just going to be straight line. So two angles that end up adding up to a straight line might be, well, the adjacent angles that we kind of covered before, right? 2 and 3 combined would flatten out. So they would be supplementary angles. And you might run across this in terms of, in examples, you might have, what is a supplementary angle to 65 degrees? And you would have to say, okay, well, if they add up to 180, then 180 minus 65 would be 115. You'd be like, 115, that's the answer. Call it good. Now, complementary angles is the other one that I always forget which one is which. I would like to have some easy way of telling you to remember these two, but I don't. Now, in terms of all the crazy amounts of vocab and stuff, supplementary and complementary do pop up here and there. So those ones are good to have down for sure. And these ones just add to 90 instead of 180. So if I wanted a complementary angle to 65, it would be 90 minus that 65. You would have 25 and be like, yay, I have a complementary angle. So these two angles are complementary. You have a 65, you got 25, they add up, they're 90. Vertical angles. That one's kind of hard to remember, honestly. One way to remember it is, I think the vertical phrase is actually referring to the vertex. Vertical angles are opposite from each other. They're just straight across from one another. So in this particular example, 1 and 3 would be vertical angles because they're across from each other. 4 and 2 would be vertical angles because they're across from each other. And what happens when two lines are intersecting like that is the vertical angles that are made like that have the exact same measure. So if angle 1 was 25, then angle 3 would be 25, just because you go straight across. And if you had one of those numbers, you could actually find all the other ones because you have supplementary angles on here, right? They add up to 180. If 1 was 25, then 2 would have to be, I don't know, 115? 115? No, 155? 155. Which would make 4 155, which would make 3 25. And yeah, you would have solved all. And that's actually the most likely scenario that you'll see things like this, is just being able to look at this and say, hey, if this one is this number, right across from it is that number. If these add up to 180, then this one has to be that, and then that one's across from this one, and you kind of like build your way out. Here's an example of that in a couple of slides that might make a little bit more sense of that. So other names for angles, these ones you might be familiar with. Acute angles are between 0 and 90, so they're smaller. Right angles are 90 degrees always. Usually with angles, you'll have like the little semicircle connecting the two sides. With right angles, you usually do a box. That way you can look at it and say, oh, okay, that's a right angle. Good. And obtuse angles are between 90 and 180 degrees. So they get bigger. Or you might say, what about anything lower than 0? What about anything higher than 180? Well, it's a circle. So if it was lower than 0, then it would have wrapped around on itself, and now you'd have an acute angle going in the opposite direction. If it's bigger than 180, then you just have an obtuse angle pointing in another direction. So those don't necessarily have terms purely because you're not going to worry about it. So parallel and perpendicular lines. You might be familiar with this. Parallel lines run alongside each other. What that means is they have the exact same slope. So if one's going up at a rate of 2/3, the other one's going up at a rate of 2/3. Perpendicular lines, that's where the lines are intersecting and create a 90-degree angle. So, you know, we have like a T there, but it could also be like a plus, something in that rough shape. But yeah, that's pretty much it. And then you have the examples of not parallel or not perpendicular. If it doesn't go straight alongside each other like parallel, or if it doesn't go through perfect 90-degree angle like perpendicular, then you usually have neither. Most of the time you'll be asked questions on, hey, here's a line, hey, here's another line. Are these parallel, perpendicular, or neither? Pretty self-explanatory. Angle pairs. These ones are fun. So for this particular example, you would have two parallel lines, and then another line's just chopping straight through, right? So two parallel lines are intersected by another line, and it ends up forming 8 different angles. So the 4 angles between the two parallel lines are called interior angles, so the ones inside the parallel lines. Now, believe it or not, outside of those parallel lines, those are called exterior angles. So you got the ones on the inside, you got the ones on the outside. The ones that are a little tougher to remember are alternate interior angles. Those are two angles on the opposite side of the intersecting line. That's called a transversal. You're not going to have to know that, but there's the word. Alternate interior angles literally just means, hey, they're both on the inside and they're on the other side of that line chopping through. Okay. Likewise, if they're on the outside and they're on the other side of the intersecting line, those are alternate exterior angles. So we got interior, we got exterior, and we got, hey, if I'm looking at the other side of it, you add the word alternate. It's a decent way to remember it. Hey, look, another term. So if you can look at these and say, okay, that is clearly the exact same angle, like, because we have parallel lines, right? So the parallel lines are going to create 4 equal angles on each, on each of the parallel lines. So corresponding angles are the 2 equal angles on the same side of the intersecting line. So they correspond to each other perfectly. They're corresponding angles. So one angle is an interior and the other is an exterior. I don't think you really have to worry about that. You can kind of eyeball that, right? You look at the graph to the right, you can see one of them and see that the other one is exactly the same. Cool. That's probably all you need to know. But don't worry. You have examples for these. Oh boy, look at that. Doesn't that look fun, guys? You excited? Did I throw algebra at angles? I sure freaking did. I don't want to make one of these a fraction, but all right. So these ones, totally gonna write down in the notes. Let's just look at number 1 for starters. Terrible handwriting. That'll kind of work. That'll kind of work. Okay. So this guy said angle 1 is 2x plus 3 and angle 2 is x. And it wants to know what are those measures, right? So just looking at this, angle 1 and angle 2 are on the same side of this line, right? That means that those two are supplementary angles. Angle 1 and angle 2 add up to 180 degrees. Okay. Usually when you run into a problem like this, brainstorming like this is a good idea. So write down what you know. Write down what you can pull out of here. Might it be useful? Might it not be? Who knows? Whatever. But all I really know is these two are 180, these two are, and these two are. But all I'm really worried about are 1 and 2. So I'm worried over here. So based on those, that's a piece of information I have. And that actually might be enough. Because if both of these guys are given to me with variables, I need to be able to get an actual number out of them, right? And to be able to get an actual number out of this algebra stuff, I need to be able to set them equal to a number. I need to have something concrete that I know angle 1 is equal to, or angle 2 is equal to, but I know that if I combine them, I get this 180. So knowing that if I combine them, I get this 180, let's combine them. Angle 1 is 2x plus 3. Angle 2 is x. And those add up to 180. Well, cool. Now we have something we can work with, right? So we have 2x plus 3 plus x equals 180. Our goal here is to get x alone on one side, all numbers on the other side. Whatever x is what we're after for now, right? So first thing I'm going to have to do is combine like terms, right? Because I have 2x and another x on the same side. So you'd add those two guys together. You got 2 of them plus another one. We have 3x plus that 3 that's still hanging out there. Not playing with that yet. So the first idea is always combine as many like terms as you can. Second idea is try to isolate the term that has the x on it. Now, combining like terms got real nice for us because we only have one term with x's on it left, but it might be that there on other problems, there might be a plus 2x over here. You would have to subtract it over or subtract over the 3x, or basically you got to move it to one side or the other side. So you move all the stuff with x on one side, you move all the stuff without x onto the other side, it'll fall into place from there. Which side is which? Who cares? Doesn't matter. Something equals x, x equals something means the same thing. Couldn't care less. Okay, so we got to solve this. We have 3x plus 3 is 180. We need to get the term with the 3x alone. So we're going to subtract 3 on both sides. Now all I have left on the left is this 3x. On the right, I have 180 minus 3. That's 177. Now, for those of you who haven't done a whole lot of algebra, what I like to do is write out my entire step. My next line is an entire other step. If I'm doing anything in that step, I usually put it below my equation. That way I can look back at my notes and say, okay, what did I do to this? Oh, I subtracted 3 on both sides. Cool. Now we have 3x is equal to 177. The 3 is multiplied onto the x, so to get rid of it, we have to cancel it out by doing the opposite operation. In this case, opposite of multiplication would be division. So we divide both sides by 3. We get x is equal to whatever the heck that is divided by 3. So that's 59, I think. 59. Because 180 divided by 3 is 60, so I have 1 less 3. It's cheap, but it works. So we know x is 59. Are we done? What does that tell me? What's angle 1? What's angle 2? I don't know. X is 59. Cool. That doesn't help me, right? So we got to actually be able to say, hey, what is angle 1? Well, angle 1 was 2x plus 3. So that means that angle 1 is 2 times that 59 plus 3. What is that, 117? 120. What did I do? Oh, I see what I did. Ha ha. Going by 30. Okay, so 59 times 2 is 118 plus 3, 121. Little degree symbol there. That's our angle 1. Our angle 2, there we go. Our angle 2 is x. Well, our x was 59, so that means angle 2 is 59 degrees. We got our angle 1, we got our angle 2. That's what the question was asking, so we are golden. We're happy with this. That is what I was shooting for. Huh?
Oh, it's in our last class.
I mean, our last class was literally just, you know, looking 3D printer. Cool. That didn't suck. Let's do more. We love more. You're all excited to do more math. Nobody's been more excited to do math than you guys. Were some Greek people a long time ago writing in sand and hammering into rocks. You know, they couldn't even hope of what we use every day. We walk around with computers in our pockets. What do we use them for? Do we use them for intelligent things? No, we look at capping. That is, an iPhone is significantly more powerful than what put us on the moon. Okay. All right. So if angle 4 is 100, what is the measure of angle 1? 80, right? Because angle 4 and angle 1 are going to be 180 degrees. They're supplementary angles. So if angle 4 is 100, then angle 1 is 180 minus that 100, right? Okay. I'm doing this stupid draw. No. That would be so you probably guess number 3 we're going to write down. You got algebra stuff. How many of you guys hate algebra? Cool. Yeah, you're really going to hate it. You're really going to hate it. I'm gonna shoehorn algebra in every chance I get. How do you get good at something? Well, you hate it until you don't hate it anymore. That's kind of what happens in your when you're taking a math class. You're like, okay, I hate this. All right, let's move on to the next thing. Okay, I hate this more. Can I go back to the last thing? I was starting to get the hang of that. And that's kind of how math class goes. You just got to hate it for a little while longer. So, number 3. We're given angle 2 is 30 and angle 3 is 3x plus 15. A lot of smudges. And it says specifically, what is the value of x? So when we find that, unlike last time it asked for the angles, this time it just wants to know what the heck that number would be to make these values true. So we look at number 2 and number 3, and we say, okay, well, like most of these options, these guys are going to be supplementary angles. 2 and 3 are going to add up to 180, right? Stupid smearing pen. If anyone wonders why my ink smears and it looks like it's taking forever to dry, that is because this is a reusable rocket book and erasable ink. So I have used this same page God knows how many times. I scan it, I wipe it, bring it to the next one. Efficiency. So guess what we're going to do right here? Exactly what we did before. Gonna add both of those and set it equal to the 180. Angle 2 is 30 plus angle 3, that 3x plus 15, that equals 180. Where are you, water? Hi, water. Only talk for an hour and a half straight for so long, you know? They didn't tell me the class was 2.5 hours when I was taking the job. All right. I've never even taken a 2.5 hour class. So respect to all of you. Because I would have just, I am a lazy human being. I would have just crapped out. I'm like, nah. That's why I only have an associate. So many people I've tutored over the years have bachelors, maybe even masters. And I'll tell you one thing, I'm terrified for the future of youth education because I've tutored a lot of elementary schools. Like, when am I ever going to use this? You want to teach people. When are you not going to use this? Oh yeah, what was I doing? Okay, math. All right, so we got some like terms on this side. The 30 and the 15 will go together nicely, right? So we'll have 3x plus 45 is equal to 180. Now we need to get that 3x term alone. So I'm going to subtract the 45 from both sides. I should be able to do that in my head, but I've been awake for a very long time now, so we are embracing Mr. Calculator. There's no shame. So 180 minus 45 is 135. Get the x alone, we got to divide off the 3. So 135 divided by 3 is 45. So is that 45 degrees? No, because all x was a piece of this angle. But that's what the question was asking. It wasn't asking for the value of the angle. It just wanted to know what x is. All right, there it is. We're good, we're done. But when you have a word problem or something like that, make sure you work it out, but go back to the problem and read it and see if your answer makes sense. Because a lot of times it's not gonna. You're gonna be like, oh God, that's the wrong answer. I found this thing, but the thing is not what I was after. And then you gotta fix it. But that is a lesson that I should have learned and I never did. I got a lot of A's, never got 100%. All right. Oh, look at that. Look at that. But the nice thing is that I don't have numbers to throw at this. We're just describing the relationships. And describing the relationships is, well, everything I talked about in what, like 8 slides? There's a lot of slides, right? A lot of that. Don't like that. So between 1 and 8. Nope. Where are you, Mr. Spotlight thingy? So angle 1 is over here. Angle 8 is over here. So they're on different sides of that intersecting line. So we know that the term is going to have the word alternate in it, right? They're on the outsides of the parallel lines, right? They're on the outsides, so they're exterior. Alternate exterior angle sounds pretty nice, right? They're alternate, they're exterior, alternate exterior. You put the word angles at the end of it if you feel like it, but I don't. Between angle 2 and 3, those are right next to each other, right? They're across from each other, across that vertex. Now, based on that, we know that these two angles have the same measure, but remember those ones were called vertical angles. Vertical angles. Between 3 and 4. Well, those are right next to each other on the inside. I guess we could have the word interior. That would work, but they don't have anything for interior sharing that line, right? What do we have that they would be sharing this line between them? They make us a flat line. Those would be supplementary. Because 3 and 4 add up to a straight line, they add up to 180 degrees, so they're supplementary angles. Yeah, that. Thanks, autofill, whatever. And then angles 3 and 6. 3 and 6 are on the other side of this line. And they're on the inside. Well, on the other side, if it's jumping sides, we know we have to have the word alternate on there. And they're both on the inside. So how about alternate interior? You know what? One more of this. So we're gonna be cheap. Make a 5. Say we want to know between angles 3 and angle 7. So the main thing I wanted to add that on, I think that's the only one we didn't actually have an example of here. Other than a complementary angle, because how the heck am I going to do that? Those ones add up to 90. We don't have a 90-degree angle anywhere. So angle 3 and angle 7 are on the same side of the line. So we know we're not going to have that word alternate. One's on the inside and one's on the outside, so we don't get interior or exterior. So we got to think, okay, what other terms have we had? What else have we had? Well, let's scroll back some slides here. Scroll back some slides here. Hey, it looks like that, right? Corresponding angles. That's the one that I would probably miss. Those would be corresponding angles. They correspond to each other. They are linked almost. On each of those intersections, they are basically the same thing, right? So they correspond with one another. So how do we feel about that? Do we hate it? Is there too much crap? Too much crap to remember. I looked at this and I was like, how the hell am I going to teach this? There's a lot, right? But just based on this one slide, we kind of covered everything. We didn't cover complementary, because complementary angles add up to 90. But everything else, supplementary angles add up to 180. That was number 3. That was angles 3 and 4. We can say that if it jumps over the intersecting line, we'll use the word alternate. We can say that if they're both on the outside of the parallel lines, they're exterior. If they're on the inside of the parallel lines, they're interior. And if they're basically the same angle on each intersection, then they're corresponding. So if you get the ideas behind all of these problems right here, you're pretty good. That's pretty much it. Now, in terms of what you might see on a test, this could be very well be something you would be asked, is which of these options are these angles. But another thing might be, hey, if angle 2 is 100 degrees, what is angle 8? wouldn't be 100 degrees because look at angle 2.
Oh,
That's in the big spot. And then angle 8 in the little spot. Huh? Wouldn't be 50. They both add up to 180. So if one's 100, the other one is
80.
80. So that means if I looked at this graph here, angle 2 is going to be the same as angle 6. And since we got vertical angles happening, it is also going to be the same as 7 and 3, right? So all of those angles are exactly the same. And since we just figured out that angle number 8 is 80, cool. 5 is 80, 4 is 80, 1 is 80. So you can kind of see it build from there, right? And if you could see that, that pretty much solve any other problems they might throw at you. You can see which ones are the same. So angle pairs, not fun, right? Want to see worse things? Probably Google angle pairs and see what happens. I don't know. You know what? I'm curious. Let's Google it. Angle pairs. What we got? Look at that thing. I'm glad I didn't give you that. Yeah, I don't like that. I don't like that at all. Go away. Go away. Yeah, but believe it or not, every single example you'll ever do on these of a line intersecting two parallel lines is gonna look about the same. So if you get that one slide down, you kind of got them all down. Oh, look, there's a way you could complicate it. You know what? Where is it? Where is it? Where is it? Shut up, I don't care about you. Shut up, where are you? Where was it? Oh my God, I hate everything. Hey, copy. Oh my God, no. Huh. Paste. Intellectual property theft. Look at text. No. Let's just figure this one out. Yeah. Anything with numbers on those? Anything better with that? You know what? I'm just going to totally just make my own. Bear with me for a second. Not actual bears. We don't have any, you know. I guess Nevada, we do have bears. I haven't seen any bears. Seen a lot of deer. Almost hit a raccoon on my bicycle once. That was literally a couple of weeks ago. You'd think, no, oh, is that in the middle of nowhere? No, this is on Hot Springs. Almost hit a raccoon. All right.
A week ago, there was a bear running through the neighborhood downtown Carson.
Was there?
Yeah.
Oh my God.
Right after I got off work,
I would have totally died trying to put a Yogi Bear hat on him.
Those on ring, man. I have a ring, so anyone in that neighborhood just post it.
yeah.
That's pretty good.
I would have 100% died. Oh my God. I am one of those idiots like, you're a murder creature. I want to pet you.
No, and it's crazy how close people would get and not even know it was right there or right over the fence.
Well, you know, they're just hanging out.
Yeah.
You know, they're doing their thing. I've 100% been standing next to deer and didn't notice it. I mean, you know, they're trying to do their best statue impersonation, but you know. Usually you see deer really early or really late, but I was riding my bike down the road and between Carson Street at Walmart, I just was going down the road, middle of the day. There's just a deer chilling somebody's yard. I stopped, I looked at him, he looked at me. It was very much a what moment. But yeah, I took a picture before that, before one of the neighbors ran out with his camera. Oh my God, honey, look at that deer. Man, he just wants to hang out. Don't yell at him. Cool. So, what would be a good question on this? What are the measures of all angles? What are all of them? What do we got? Well, based on what we've learned, let's start from number one and go with what we know. We know number one is going to have to be exactly the same as the one straight across from it, right? So number one is equal to number three. But with the two intersections there, we also have corresponding angles. One is pretty much the same thing as 5, and 5 is the same thing as 7, right? So 5 and 7 are also equal to those guys. And likewise, it goes the same for the other ones, right? 2 is the same as 4, and that's the same as 6 and 8. So basically, all the even ones. Oh my God, getting ahead of myself. That looks terrible. That looks terrible. I can't fix that. I'm making it look worse. You ever try to fix something with a pen and it just keeps getting worse and worse? Look at a plasma donation center, and I've totally done that on a plasma bottle with a pen. Very awkward. Like, I need to turn this P into an A because it is not noon yet. Hate early morning. By the way, if anybody feels like getting stabbed and getting paid for it, you can go over by Target, and there's a plasma donation center. I got a pretty decent percentage of people I haven't named. You know, bad things happen. Got splashed with blood the other day. That was nuts. Washed my pants, came out. That was cool. That was cool. It was a very angry old lady. Yeah. What the hell was I doing? Oh yeah. All right. So, things we know. This and this, this and this, this and this. Those are all supplementary angles, right? So we know that each of these pairs would be a supplementary angles, right? If I paired angle 3 with angle 8, 3 and 8 would add up to 180. Now, where am I going with this? Well, because this 3x plus 5 is a corresponding angle with angle 8, right? Which means this 3x plus 5 is also 3x plus 5 here, here, and here. So I can tell that this 3x plus 5, which would also be here, plus this 8x minus 3 are going to add up to 180. Notice that's like 90% of the problems is figuring out what adds up to 180 and then solve it. Seems to work out nicely. So if angle 4 and angle 7 add up to 180, then 3x plus 5 plus that other thing, 8x minus 3, both of those add up to 180. like it. I'm rambling. I start talking, everybody starts frantically writing. I like it. I like it. This normally doesn't happen to me. Usually people like drop immediately. Not used to people writing. It's awesome. Love you guys. In the weirdest way you want to take that. I am not a shy weirdo. I have 100% asked a guy in a Taco Bell, taking my order, man, you all right? You need a hug? And he said, yes. And he got out from behind the counter and we hugged. Like, whatever, you know? Just exist. All right. So combine some like terms. We have things with X's. We got things without. Things with X's add together, 3X and 8X. Guess what 3 and 8 give us? 11 of them. Then we got a positive 5 and a negative 3. 5 minus 3, 2, right? If you're ever unsure of how you're adding or subtracting, put dollar signs in front of it, because you might be bad at math, but if we're talking about counting out your money, you know the answer already. That's usually how it works. I've always loved that about tutoring. I've noticed that if I do problems with money, everybody gets it. The second I drop that, I just go with straight numbers. Everybody starts drooling and eyes glaze over. Great. Okay, so we're going to subtract off the 2. Get 11x is equal to 178. That probably doesn't go in evenly, right? Going to round it off a little bit. 16.18, 18 repeats forever. So I'm just going to call it 16.18. I like that. Oops, I put a degree symbol in there, but X isn't a degree. See, this is why I never got 100% on a test. Right there. See it? Okay, so we got our X, but
Can you bring that paper down a little bit, please?
Where am I moving it?
Up or down so I can see what you wrote. Thank you.
Are you on a phone? What's the aspect? That is one phone and it's flipping. That's the case. That makes it better or worse. It can be weird on phones. It gives you the best fit, which also might cut off ends on either side. So, you know, fun stuff. So we got X, but we actually wanted the measure of all the angles, right? So angle 4 was 3x plus 5. So angle 4 was part of this group. So all of these groups are going to equal whatever 3x plus 5 is. Well, x is 16.18. So I'm going to take that 16.18, multiply it by a 3, and then add a 5 to it. I get 53.54. In this case, these are angles. If these are angles, then that's my answer. That's one of them. Now we need the other one. Well, I could go to the trouble of 8x minus 3, or I could just say 180 minus that. I like that idea better. Absolutely take the easy route. There are no heroes in math. Okay, so these ones would equal 180 minus that 53.54. We would end up with 126.46. I apologize for the fact that I am one of the messiest writers on the planet. I only apologize as much as it takes for you to forgive me for it. Past that, I don't care. Yeah. That was fun, right? You don't think it was fun? Okay, you're wrong, but that's okay. It was fun. You had fun. Let's see. What else we got? What else we got? What else we got? That's a lot. Man, how far did we make it in here? About 38 slides in. How much of this was actual math? About 28. How many slides do I have left? About 40. Okay, cool. The next step I have is, I want to teach that at the same time as the triangle. How do you feel about a short class? How does everybody feel about that? The downside is you don't get credit for that extra half hour. The other downside is I don't get paid for that. Yeah, I'll miss that $5. But the nice thing is that yeah, I really don't want to teach the next block of stuff without it all being at once. And I think I'm good. I don't know how to end a class, by the way. I've been doing this for a couple of years now. I have no idea how to end a class. You're done. Go home. I'm done. I'm done. If you didn't write your name on the or sign next to your name on the sign-in sheet over there, please do so.
What's on the end of the table?
It's over there. If you're not on there, tell me, because that happens every single time I teach class.
So if this is the first class, you said something about an email. Is that still?
Did you not get an email? Okay.
First class.
Okay. So I am going to go ahead and, oops. Am I able to stay at the hours if not lost? Okay. Well, I guess I'll get paid for it. So yeah, whatever. Yeah, I'll stay attached. If you guys want to take off, go up on Zoom there. I am in fact talking to you Zoom people. You Zoom people. Feel free to disconnect. This will be fielding questions time, I guess. And yeah, if you didn't get an email, please write down your email. Actually, were you on the sign-in sheet? Write your email.
Could I check my email just to make sure I got it?
Yeah.
Or
Yeah.
Thursday?
Huh?
Thursday, I'll come back and get it if I need it. The link.
Oh yeah.
I gotta go through a bunch of emails. That's it. I just don't want to do it right now.
You're good. You're good. Don't worry about
I'm tired too.
it.
Have a good one, bro.
Yeah, you too.
I'm tired and I have to go back to work right now.
Go back to work. Where do you work?
I do construction, so I'm doing like, I do sheetrock during the night because during the day is too
Is
hot.
that I and then an I? Sorry.
Yeah.
Okay, cool. Okay.
You just
Cool.
draw a little circle. That's how I remember.
Really?
And whenever people's names.
Okay. Okay. All right. But yeah, I will send that.
So if I missed a class yesterday, it was for like reading or English.
I have no freaking
Do I have
idea.
to email that teacher to see if they can send me whatever they worked on, or?
Everybody
How does that
teaches
work?
it differently, and I'm not sure how that's taught.
I mean, I think I have that class tomorrow.
Could always,
I'll just ask tomorrow.
you could always just wait, yeah.
Yeah, 'cause sometimes I'll send an email and it won't pull out.
Yeah, I don't think anybody's gonna respond by then.
Thank you.
Okay, I see your question. Is it optional or no? Do you really need the hours? If, actually, I know how to get you some hours. I know how to get you some hours. Essential education. Do you have a login for that?
I do not.
Ooh, okay. Let me turn off sharing. I'm going to see if I have a login for you. Because everything on Essential Education is actually logged for those hours as well. So you could totally be signed in and working on lessons on there, and it'll go ahead and you'll be counted for those hours.
Okay. Is it like an app? And then I just log in with it, look through the PowerPoint that you presented, and then I'll get the hours still?
Yeah, you go to, I'm kind of wondering if there's a way to see it on WNC.com. Probably not. Sorry, I'm hunting.
It's fine.
Yeah, did you get the email I sent you?
Yeah, I believe so.
Okay.
Yeah.
That's gonna be the easiest way, and you can bookmark that page. I don't know. I know it works great on computers. I don't know if you're using a phone or not, but I don't know how that would come out. Let's see. I do have a login for you. I'm gonna go ahead and
And this login is for what again? I forgot it. The
That's for the essential education thing. It'll be.
Okay.
I'm gonna go ahead and send you this. Okay.
And that thing that I log on with, it tracks my hours for me just automatically.
Yep.
Okay.
Love it. Love it. And the nice thing is that it will actually, like it gives you like, when you log in the first time, make sure you give yourself some time, because it'll give you like a little pre-test thing. You don't have to stress that. It's literally just to see where you are, and it'll spit you into a lesson that you should be learning. So, and then it'll build up from there. So it's kind of nice. It covers the same topics that I cover in class, but I go a little bit more in depth. It shows like a two or 3 minute video. That's really it. Let's see. I'm setting up. I'm going to go ahead and send you a copy of your login, as well as I'll just have it typed out.
Okay, so this is through email, right? And then
Yeah, that way you don't have to like stress writing something down out of the chat.
okay.
And then, if there's anything, if you can't get into it for some reason, I don't think I can mess with it. At that point, you would want to talk to Elizabeth, because she's the one who sets up these accounts.
Okay. Well, it's fine. I'll let you. I'll figure it out either way. But thank you for today's lesson. I appreciate that.
Yeah, of course. Yeah. And then your email is first name, last name, 118 at Gmail, right?
Yes.
Okay, cool. So you should have an email in a second here. I typed out the login stuff. I even put the link to Central Education in there just for funsies.
Okay.
And I attached your original login page. So you can actually have a copy of that sheet as well.
Okay, great. Thank you. I appreciate that.
Yeah, absolutely. Other than
All right.
that, is there anything like you would say you had trouble with tonight, like, or anything you have trouble with that you want to cover before I take off for the evening?
No, I think I pretty much got everything down. I wrote a lot. Like I was just writing the whole time and looking back and forth and taking notes. So I'm really good at that. So I was just wanting to see
Nice.
just about the hours and stuff. So
Yeah, absolutely. And yeah, like I've said, if you have any questions at all, please let me know. I am always down for, you know, whatever. If you run into something on Essential Ed and you don't know what to do with it, send me an email and I'll help you out. Now, granted, I got a big job, so I mean, I don't know if I'd be immediate, but I would help you.
all right, thank you. You have a good night.
Yeah, have a good one.
You too.